Let us get started. Renaming columns and indexes in Pandas. Learning to rename columns and indexes helps make your data easier to understand and work with. We will use the Titanic dataset for this lesson. Let us explore how and why to rename columns and indexes. Running the cell now. Think of places where column names are unclear and how renaming helps. Let us load the Titanic dataset and see what it looks like. We will turn off warning messages to keep things clear. We are now setting up our Titanic dataset, a real-world data sample. We import Pandas, the main tool for handling data tables in Python. Import NumPy as NP. We set the random seed to 42 for reproducibility. We give Pandas the exact address where the Titanic data is stored online. We read that data into memory and call it DF, short for DataFrame. Let us check how many rows and columns the table has. Let us peek at the first few rows to get a sense of the data. Running the cell now. This output shows the initial shape and first 3 rows of the Titanic dataset, confirming it has 891 rows and 12 columns. Notice the original column names like a passenger ID, survived, and a P-class, which are not yet renamed and may be less intuitive. This setup highlights the need to rename columns for clearer, more meaningful analysis in the next steps. Let us understand why renaming is needed. Why rename columns or indexes? Column names may be long, unclear, or have typos. You may want to match column names across datasets. Clean names make analysis easier. Running the cell now. Let us check what the original column names are in our DataFrame. Let us list all the column names for the Titanic DataFrame. Running the cell now. Here, we print the original column names of the DataFrame to see their current state. Notice that some names are lengthy or not immediately clear, such as SIBSP and Apache, which might be confusing or inconsistent across datasets. This step helps identify which columns need renaming to make the data cleaner and easier to work with. Which names could be confusing or too long? Let us see the main tool for renaming, the rename method. Basic renaming with rename. To rename columns or index values, use the .rename method. You provide a mapping, the current name, and the new name you want. Running the cell now. After typing, consider what you might rename first. Let us rename some columns to clearer names. Suppose the term sex is confusing, or P-class is not clear. Here, we create a new data frame where sex becomes gender, and P-class becomes passenger class. Let us print the first several columns to see the change. Running the cell now. Here we see the columns after renaming sex to gender and P-class to passenger class. Notice how the original column names are replaced as intended, while the others remain unchanged. This confirms that .rename selectively updates specified columns without altering the overall data frame structure. Try renaming columns in your own data, even if just one at a time. Notice that our original data is not changed. When you use .rename, the changes make a new data frame unless you set InPlace as true. Let us check whether the original has sex still. Let us check if the column gender was added in the original. Running the cell now. This output shows that the original data frame still contains the column named sex but does not have a column named gender. This confirms that using .rename without InPlace equals true does not modify the original data frame, illustrating the importance of specifying InPlace equals true if you want to rename columns permanently. Now let us update the columns in our existing data frame. By using InPlace equals true, we tell Pandas to edit our data directly. Now sex becomes gender, and P-class becomes passenger class, permanently in our table. Let us view the first several columns once more. Running the cell now. This output shows the updated column names after using .rename, with the inplace equals true option to modify the data frame directly. Notice that sex has been changed to the gender and p-classed at passenger class, which makes the column names more descriptive and easier to understand in your analysis. If you make a mistake, you can always rename a column back later. Let us try renaming more columns at the same time. You can rename as many columns as you want in a single dictionary with rename. Now we make age extra short and give embarked a more clear name. Let us check these updates in the column list. Running the cell now. The output shows the first 7 column names after renaming, where age has been abbreviated to A and embarked has been renamed to port of embarkation, though not shown in the first 7 columns. This confirms the .rename method updated the specified column names correctly, illustrating how you can easily customize column labels to make your data frame clearer or more concise. From here, pick names that make sense for your team or your project. Let us explore renaming with bulk changes using string methods. Renaming columns with str methods. When columns have patterns such as extra spaces, uppercase letters, or special characters, use string methods. For example, you can make all columns lowercase or strip white space. Let us see this in action. Running the cell now. Pay attention to subtle changes in your labels. Let us fix common patterns, different cases or extra spaces. If your columns come from messy files, quickly standardize them. Here, we make every column name lowercase and remove extra spaces. Let us print the result to see the effect. Running the cell now. The output shows the first 7 column names after applying string methods to make them lowercase and remove spaces. Notice how original columns like passenger ID and passenger class are now simplified to passengerid and a passenger class, improving consistency and ease of access. This demonstrates how str methods help clean column names for smoother data manipulation. Try this after loading new CSVs to make code easier. Now let us clean things further for display. If you want nice-looking headers for plots or reports, you can adjust style. We swap underscores for spaces and capitalize each word. Let us view some columns to check the results. Running the cell now. Notice how the code transformed the column names by replacing underscores with spaces and capitalizing each word, making them more readable. For example, passenger underscore ID became a passengerid, improving clarity without changing the data. This demonstrates how string methods can clean column names to enhance dataset usability. Remember, better names help when sharing your data with others. Let us focus on the data frame index and why that matters. Renaming the data frame index. To rename data frame row indexes, use the rename method with the index argument. This is helpful when your index is not just numbers, for example after grouping. Running the cell now. Where have you seen row labels that look confusing? Let us walk through making the index more meaningful. Sometimes you want the row labels to mean something. Here, we set passenger ID as the row label. We rename the index labels for first 2 rows as an example. Let us check the first few rows for the new index. Running the cell now. Here, the output shows the data frame after setting passengerid as the index and renaming 2 specific index entries to more descriptive labels. Notice how the first 2 rows now use first passenger and second passenger instead of numeric IDs, improving readability without changing the data structure. This demonstrates how rename with the index argument allows customization of row labels after reindexing, which is especially useful for making grouped or indexed data easier to interpret. Practice with setting custom index names that help track data. Let us start over and reset the index. If you ever want to go back to a plain row number for each data point, use reset index. We return the data frame to regular integer row labels. Let us preview the first rows to check. Running the cell now. the output shows the data frame after resetting the index, turning the custom index labels, first passenger, second passenger, back into a regular column named passengeried while restoring the default numeric index. Notice how the original index is preserved as a column, which is key for retaining important information when switching between indexed and default views. This step prepares the data for further manipulation without losing the index labels created earlier. Try resetting when you need to add new data and want stable row numbers. Let us talk about a common headache in renaming. Common pitfall: in place versus not in place. Using in place equals true directly edits your data frame and you cannot undo. Without in place equals true, your original stays unchanged unless you save the result. Use caution, decide if you want to keep the changes or not. Running the cell now. Which style do you prefer? Try both on your own data. Let us try interactive renaming. Let us allow the user to type which column they want to rename. The user types the current column name. Next, the user types what they want it to be. We make a new data frame with the updated column name. Let us print the columns to check your change. Running the cell now. Here, the output shows the updated column names of DF2 after renaming the first as ticket prices without using in place equals true. Notice that the new data frame DF2 reflects the change, but the original DF remains unchanged, highlighting the importance of saving the result when not using in place equals true. This reinforces the lesson on controlling whether changes affect your original data frame or a copy. Try other columns and choose your own names as practice. If you are enjoying these hands-on lessons, do not forget to subscribe and like the video for more. Suppose many column names have different cases or spaces by accident. Cleaning up header names in bulk makes code easier to write and debug. We change all column names to lowercase and drop any spaces. Let us look at the new standardized column names. Running the cell now. Here, the output shows the standardized column names of the data frame, all converted to lowercase and stripped of spaces, which helps avoid common key errors. Notice the shape remains the same, only the labels change, highlighting that the code generates a new index object without altering the original data frame columns in place. This aligns with the lesson's warning to be mindful when modifying data structures with or without in place equals true. This makes column selection quick and error-proof when coding. Let us see how you can start over if column names get too messy. Sometimes, after many changes, you want to reload the original column names. We simply reload the data and check that the headers are restored. Let us print the columns to confirm. Running the cell now. Here, we see the original data frame columns restored by reloading the data from the source, which shows that no permanent changes were made to the original dataset. This highlights the key lesson: without using in place equals true, or saving changes explicitly, your original data frame remains unchanged and can be restored anytime. Always be deliberate about whether to overwrite or keep a copy when modifying data. Let us see how renaming fits into real projects. Use case: renaming before merging. When combining datasets, names must match exactly. Renaming ahead of merging helps ensure the join works right. Running the cell now. This skill is important for everyone who works across several datasets. Let us format columns for Python best practices, snake case. Sometimes, Python code is clear if all columns use snake case, with words joined by underscores. We make a copy so we do not change the original by accident. We switch spaces to underscores, fix extra underscores, and make all letters lowercase. Let us preview to see if all columns fit the Python style. Running the cell now. This output shows the first 7 column names after renaming them to snake underscore case, ensuring all are lowercase with underscores instead of spaces or double underscores. Notably, columns like passenger ID became passengeried and passenger class became passenger class, which standardizes naming for seamless merging. This step is crucial because consistent column names prevent key mismatches during dataset joins. Try this step whenever you start a new data analysis project. Suppose you want generic names for all columns, for privacy or experiments. You can replace the entire column name list with your own list. Here, we create new names with numbers for every column. We assign them to the data frame. Let us check the result, where each column is now just a feature number. Running the cell now. Here, the columns were renamed systematically to a uniform format, feature_0, feature_1, etc., which helps avoid mismatches during merging. Notice the original mixed column names replaced by consistent feature labels, preserving all data and structure. This ensures the join will align correctly when merging datasets by column names later on. This is helpful when prepping data before sharing or machine learning. Let us pause and apply what you have learned. Practice and apply. Make all column names lowercase. Remove all spaces, replace with underscores. Try renaming survive to outcome. These steps will help you solidify your new skills. Running the cell now. Try these in your own Jupyter notebook and play around. Let us wrap up and revisit the main ideas. Recap: renaming columns and indexes. Use .rename for specific changes, use string methods for patterns. Always check your results after renaming. Clean names save time and reduce mistakes. Practice and you will master tidy data frames. Running the cell now. What can you do next to improve your data projects? Thanks for joining this Pandas lesson. Thank you for learning with us. For more Python and Pandas lessons, subscribe and click the bell. See you in the next video. Running the cell now. Share this video or comment below your favorite tip about renaming.